Welcome everybody. Welcome to the Reactive Summit, which runs globally online. For those who are just joining us, this is the first time we run Reactive Summit as the conference of the Reactive Foundation, which is a Linux foundation. And it's an umbrella project. We just announced the addition of R2DBC and Reactive Streams, and our socket is a core original project, and there are several other projects coming in, so we're very happy about that. And we basically have this reactive community going on for many years, right? There was a conference called ReactConf, which Jonas Bonner and others did in 2014 in San Francisco, which was extremely cool. It was held in a comedy club, and the marquee read an asynchronous event. Right, so I think we'll do a panel in that spirit. We want to explore all things reactive. There is a lot of questions. What does reactive mean? There are multiple open source projects saying that they're reactive, right? There are different meanings of this. So we want to explore all of these topics, and we have a very illustrious panel here. It's basically it's a reactive family. Right, we have multiple folks from the companies which do reactive projects, and we have multiple folks who are on the Reactive Foundation Advisory Council. So we have, because of the Zoom, we can actually have a bigger panel, and we have a lot of time. So what we're going to do, there are two moderators, me and Dean Wampler. Dean is a veteran of all things reactive, all things Scala, and all things distributed. He was at Lightband before. So kind of the trick to this conference and community is that people are the same, their labels change, right? It's like startups, we outlive startups, community outlives startups. Companies merge and change, people stay the same, and ideas, are very solid. So Dean is now a principal software engineer at Domino. He was at Anyscale in between, and he will talk on Ray, which is a distributed computing system at scale by the Bay, which is Thursday and Friday. So we have all these threads going on. Dean and I will moderate. And the plan is we will do short introductions, but kind of a little longer than just the introduction. We'll ask everybody to say, how did they come to this kind of space, and what is the angle on reactive? And then Dean and I will kind of pick up on the themes and ask questions. All right, so now I'm passing on to Dean Wampler.
Hi, Dean Wampler. As Alexy mentioned, I've been working for Domino Data Lab, a lot of Scala again. We're actually hiring if you're looking, and also I'm working on the third edition of Programming Scala for O'Reilly on Scala 3, so that's a kind of exciting change as well. So who should go next? Maybe Sergey?
Sure. Hi, everyone. I'm Sergey Bykov. I've been with Microsoft for a long time. I work in product groups in research, back in product groups, work on this Project Orleans for like over a decade. And I recently left and joined Temporal Technology, a very ambitious startup. So I guess my first exposure to the whole domain of reactive, if I can call it that way, was sometime in mid-2000s. When I was part of that watch, and I was part of these efforts of trying to build what appeared to be cloud scale services with techniques and learnings from like the prior decade. And I mean, you probably remember how painful it was, how it's ad hoc solutions for the problems that we take for granted today, like state partitioning, consistency, like choices, autonomy of components. All of that was kind of painful to watch how people were reinventing those wheels. And later, I was involved quite a bit in helping build gaming services. And gaming is an interesting domain because game developers always push envelopes in all these directions. And they have probably the most demanding audience. If something doesn't work, gamers just yell and scream and go to Reddit. And it's just very demanding stuff. And I've seen there that these trade-offs that we had to make around availability, like high availability, low latency, some consistency choices, like a difference between stats for games versus the commerce operations, all this whole mesh of that stuff. And my angle through like all of that has always been like about the programming model. Like that's what always interested me the most. I view that as that's how we help developers ourselves to be more productive, to write less code and achieve better results, to not getting woken up at night. And programming model, like to me, it's not API. It's kind of the mental model. It's how we think about the problem, what abstractions we use, how we like construct solution in our head first before we write any code. So that's kind of the space that's been my interest. And been talking to a bunch of people over the years, like Roland, who is not here, like Jonas, Kiki, Evan, and like we all like looking from different angles at the same set of problems. And the question whether future is reactive, to me, it's a non-question question. Of course, we all want to build systems that they're reliable, provide great experience with like low latency, high throughput, the cheap to run, cheap to operate, and developers have a good night's sleep. So that combination makes the answer obvious yes to me.
Thank you, Sergey. Next is James.
All right. Well, thanks for having me. I'm James Ward. Let's see a little bit of history. When I was at TypeSafe, now called Lightbend, many moons ago, we were sitting around and we were like, how do we like take all this stuff that's different about how we're doing things in Scala and in Akka, and how do we like put a name to it? And at the time, there was some people like using the word reactive a little bit here and there. I remember Brendan McAdams had Reactive Mongo, and there's a couple other libraries out there that were using the term reactive. But at that time, reactive was mostly used as a word to talk about how spreadsheets were like recalculated. And that was the most of the term where the use of terminology for reactive came from. And we're like, well, people are talking about reactive a little bit, like Brendan is like everything should be reactive, and Brendan's awesome and also kind of crazy, but awesome. And so we were like, all right, like let's just start calling this all reactive. And so we did. We're like, all right, it's all about being reactive. And then we're like, but wait, we have to like actually define what reactive means. And so I remember like sitting in some hotel lobby with Jonas, I don't know, probably after Scala days and too many drinks or something like that. And we're just like, what are the traits of reactive? And so we came up with the original 4 traits of reactive in some hotel lobby in New York. And so then, it started to grow from there. And so I got to do a lot with reactive since then. Scala Futures were, I think, kind of my first real area of doing reactive, maybe like some Node with callbacks and that kind of stuff, and actors certainly. Recently, I've done a bunch with Kotlin coroutines and done reactive through that. Also, of course, Webflux and the Spring stuff and the RX stuff. A lot with Akka streams, and I'm like, these are awesome ways to do reactive, and they've certainly made it a whole lot better than callbacks. Like no one should be doing reactive with callbacks anymore. That's just terrible. But I think we still have a ways to go so that we can really make reactive approachable to most developers out there, and make it approachable in a way that is composable, that is resilient, and has all the other traits of reactive. So while I think the future is certainly reactive, because it's the best way that I think we've found to have resource efficiency, I don't think it's quite easy enough yet. What I kind of imagine at some point is that if it's really about, in a lot of ways, about resource efficiency and letting our programs like say, all right, I'm going to be done for a while until you need me again. It's in some ways like memory management, where we used to like have to think about memory management, and then garbage collectors and the JVM made it so we don't have to think about memory management anymore. And maybe it's fibers, maybe it's the JVM Loom stuff, but I think ultimately we want to get to the point where it just is managed for us. Like we hopefully don't have to think about reactive in the future. We just are inherently, transparently reactive. And so, yeah, that's my thoughts and history on reactive.
Thank you, James. Next is Josh. I think you're on mute.
There you go. Sorry about that. Good morning. Good afternoon. Good to see you all. This is so cool. How cool is this? I wish we could all be in person. It's really nice to see you all. For those of you on the panel, would you mind if I took a photo? Like, you accept my GDPR cookies? If so, would you pretend, just get your camera on, pretend like you're happy. I'm gonna take a photo quick, waiting for admin and support. I guess that's, and then, okay, I think we're okay. Ready, steady, pretend like you're happy. Thank you. Good. So my name is Josh. I work on the Spring team, and that changes. So actually, I think at the beginning, the company was Pivotal, which I appreciate because I love Pivotal. But now Pivotal's part of VMware, so I'm actually at VMware. But I started on the Spring team at VMware back in 2010, and so I've been on the Spring team in an enduring fashion for the last 10 years, like a stink you can't get out of your gym socks. I've just been there. I've just been lingering like a smell. And I love reactive programming. What little I understand of it, I love it. I have it's hard for me to pontificate on the sort of future of it, because I don't know. All I can see when I think about it is more uptake. So James just talked about the idea of Loom versus coroutines or maybe not versus, but that all these things held in the same brain. We have to consider them all. And I don't know. My experience with reactive programming has come from, I wanted, let me try again. I'm not that smart. And so as a result, I needed something simplifying. And so when I discovered reactive gave me a consistent way to describe all these asynchronous, potentially latent, potentially unbounded, potentially eventual whatever sources of data, I was like, that's simplifying. That makes my life much easier. So I don't have to have a different API for Kafka or RabbitMQ or for WebSockets or SSE or whatever. It's just publisher, right? So that was great. I'm a big fan of that because it makes my life easier. I don't have much hair left, and what little I do have, I don't want to lose it fiddling with different ways of representing asynchronous streams of data. The other thing that was interesting about reactive programming was that because it's the same kind of thing, because it's simplifying, it's also composable, right? Some of the integration code goes away, or at least a lot of it does, right? So now I'm just dealing with composition on publishers. I said, well, that's great. I can now, in the distributed systems world of microservices and cloud native apps and all that, suddenly I have a toolkit that gives me everything I need. So I was very excited about that. And then, yeah, there's also the resource efficiency discussion. And obviously, different languages and different organizations and different ecosystems have sort of handled this differently. I'm a Kotlin, I'm a Spring developer advocate on the Spring team. I'm a Java champion, but I'm also a Kotlin Google developer expert, and I love Kotlin. And one of the reasons I love Kotlin is they have coroutines. But then coroutines give you a way of saying, this is a thing that's going to happen eventually. I'm going to step away from the thread. Somebody else can give me a callback and rewrite the code so that the continuation picks up at the end of the asynchronous pipeline. So that gives me, and if you're using Spring support for building reactive applications in Kotlin, that just becomes coroutines if you want it to be, right? You can use the reactive streams APIs, or you can use coroutines behind the scenes. We're backgrounding all that work to a reactive stream. So I like that, but I do kind of wonder what that means. So I do kind of wonder about the so-called colored functions problem. I wonder what we can learn from Go, for example. Go has solved that problem pretty well, but on the other hand, even there, they've got one kind of function. It's all, you don't have a way of flagging a function as being asynchronous in Go. And yet, to do anything meaningful for coordination, you need to use this very specific paradigm, a very messaging-centric paradigm called Go routines. And so I think we're kind of, I like Loom. Loom gives me better resource efficiency, but it doesn't address the, how do I write software in such a way that I can deal with the reality that things are asynchronous, right? And so with Go, you have Go routines. With reactive APIs, you've got reactive APIs. And I'm just wondering, how do we get that to all line up so that we get reactive resource efficiency and the programming model that allows us to describe volatile potential network sources, as reactive programming does, while also making it simpler, like Project Loom aims to do, right? While removing a lot of the inefficiency in the core SDK. So I don't know what the future holds. I'm a really bad person. I'm here to listen to you all, basically. I'm a really bad person to have in this panel. I have no idea. So thanks for having me.
Thank you, Josh. That was awesome, and we're super happy to have you with all the kind of experience and the perspective from Spring and our socket. I think next intro is from Kikia Carter. Take it away, Kiki.
So I am Kikia Carter, and I too have sort of the back in the day introduction with Reactive, and I can even go right before that, because I remember one of my earliest jobs. I'm an engineer at Lightbend right now, and one of my earliest jobs, I ran into this book called J2EE without EJB, and it just like it just blew my mind. And here I am telling the whole world about Spring, and I'm like, I worked at a bank at the time, and I'm oh my God, we got to just Spring it all. And it was a very eye-opening moment for me. It was one of those shifts, one of those paradigm shifts that you experience in your job and what you're doing, and it just changes everything. And then I hit that again in my career when I came into Reactive. So this was during the TypeSafe days, and I'm like, wait a minute, I can, I had that moment where I'm thinking, wait, I can build things out that have these tenets, these characteristics, and I can do it using a model that even more closely resembles reality than IOC or inversion of control pattern. And to me, that again just kind of blew my mind. I was like, wow, this is incredible. It's incredibly elegant. And that was some of the things, like as I've gone through my journey, I've looked into things that have made my job and the code that I write and my purpose more elegant in what I do. I really appreciate that. And I appreciate simplicity, making things more beautiful. And so through that journey, I've worked with TypeSafe as a customer of TypeSafe, using TypeSafe, using Akka, Scala, the stack to build out platforms for Fortune 500 companies. I've built out reactive platforms, reactive applications. And in that experience, I learned a lot about what I feel like is, reactive now, and what you need to use, the skill sets you need to build reactive today, and where I feel like there's a gap in the future. And today I am working at Lightbend on the other side, and a lot of what I'm doing now is actually looking at how we can bridge some of those gaps of usability, how we can make it more accessible, how we can do things like mentioned earlier by James, let's make this invisible. Let's make reactive something that just is, something we don't have to think about. I don't have to stick my feet out on the bottom of the car and run with the car. I actually just can turn a key and the car does its own thing. And we really want to get to that. And for me, as I'm thinking about, okay, this question of what is reactive the future? I have to say, I feel like reactive is right now. I feel like we're in a moment where things are being disrupted in such a way that reactive is now. Reactive is not the future. Reactive is now. And I would posit to say that the future is going to be even bigger than reactive. There's going to be another shift, right? And you have these tenets of reactivity and what we think it means. And but if you look at the way technology is changing, you look at that chessboard example where things have changed 4 squares, 16, 30, you get this Fibonacci almost exponential change going on. I feel like we're in a middle of another shift. And we probably couldn't imagine, like, no, things can't get any crazier than they are today when it comes to data, the amount of data that we have and the technology that we're using and so on and so forth. But I feel like it will. I mean, right now, you look at us, we're all on a panel, we're in Zoom chats, and one day doing this, someone's going to look back on this and say, how analog was that? These people were like looking at each other in kind of 2D screens and so on and so forth. And now we're all walking around like holograms, and we can like virtually smell each other and stuff like that. And I feel like we're not very far from that. And unless we can start making the tools, the hardware, everything really compatible with this world and what we're talking about in software and development engineering, unless we can make it more attainable, more ubiquitous, simpler to use, and even easier, even removing some of the effort, I don't think we're going to really be able to capitalize on what the world is, aimed to look like in the future. And I don't know if we're still going to call that reactive. We may even need another word for that, for what I think that, where I think we're going with software today. And that's my idea.
I just like to call it functional effects.
You want to put a tab on the word now? I got to put a word out before someone else coins it.
We have to move to proactive.
Proactive.
Thank you very much, Kiki. Next up is Steve Gurry.
All right. So good morning, good afternoon, everyone. So my name is Steve Gurry. I'm currently a software engineer at Facebook. I'm working on distributed systems, architecture, specifically Thrift. And I've been in the Bay Area for about 10 years, and I've been working on, like reactive system, asynchronous programming for quite a while. I've been at Twitter. I was working on a framework called Finagle, which was the base on all the architecture of Twitter servers. After that, I've been at Netflix when I was working on RxJava, and later RSocket, which is the extension of RxJava across the network. And now at Facebook, I'm integrating on Thrift some of the reactive principle that I've learned along the way. But actually, I started my career earlier, like almost 15 years ago, and I was working in the video game industry. It's funny that Sergey mentioned video games. At the time, there was a shift in the video game industry. The shift happens between, like the games that you ship on CD that are completely offline to games that are more online and then you play together and so on. And the type of interaction that you have with games is a little bit different from websites. It's not request response. You have very complex interaction, like you have players broadcasting their position. They don't send the request and wait for the response. You just broadcast the information. You have servers that basically buffer those updates in position, and sometimes they don't send all of them to all the other players. Sometimes they only send like 1/5, or they do some computation, or they do some aggregation of the data. So the interaction model that you have with games, and actually the MMO games that I was working on, was way more complex than what you have with the typical web server when you send the request and the response. And at the time, we were using a C++ network library called ACE, ACE. And there was one pattern very famous that everybody was using called the reactor. The idea of this reactor was you react to events, and everything you do is an event that you send, and then something in the code base will react to that. So obviously it was based on the EPOL implementation. So every events were basically a notification on the event base. But building application on top of those principles forced me to think about the architecture in a different way than the typical imperative programming, when you write lines of code and then you do some action, you wait for the response and so on. You had to completely change the architecture so that you need to base your architecture on events and reaction to those events. So this is my first experience with what I would call the basic reactive principles. At the time, 2004, 2005, it was not well defined what was reactive programming and what was what the word reactive means. But later, things evolve a little bit. People tend to see asynchronous programming and reactive as the same thing, and kind of merge together. Sometimes people use the word reactive for the word asynchronous. They use like abstraction like futures or observables or things like that. I think those two things are orthogonal, but they are very linked. So when you use reactive application, it's difficult to architecture your application with reactive, like event-based abstractions. But all the reactive libraries that you have in the wild basically make that easier to write. So that to say, to answer the question, is the future reactive? Probably some of it will be. And the trend that you see in programming languages, when you see more usage of coroutine, you see abstraction like channels in Go or Go routines. C++ has coroutine now, or will soon when it's actually part of the standard. More languages like Kotlin have coroutines. So definitely we can see a trend where asynchronous programming and reactive programming is converging, and it's going from a library that you have in the language to something which is part of the language. And when it's part of the language, then you can use it more easily. And it's more easy to integrate that into your architecture. So this is why I think that reactive programming will definitely increase over time. It will become more and more obvious, especially when you design highly scalable system. Definitely a reactive programming will be part of it. That being said, there will always be systems that will be classical imperative programming, and that's probably okay. But for large scale system, reactive programming will definitely be something that we will see in the future.
Thank you very much, Steve. And obviously at Facebook scale, it's very interesting what's happening. Not very many people can have this kind of problems, right? So we span the whole spectrum. So very interesting this perspective. Next is Evan Chen. Welcome, Evan.
Hey, thank you, everyone, and good morning, good evening, I guess wherever you are, saying hi from the West Coast in Canada. So my story of Reactive. So I've been, I actually didn't start out in software. I'm an electrical engineer by training, and I got into software through VMware. So hello, Josh and other VMware people. I was at VMware for 9 years, like from when they were like really tiny to when they were really huge, and through that time, you start out with like lower level of the stack and gradually move my way up, and through that time, nobody really like talked about like, there's no notion of like reactive, whatever. VMware was very much a, people were talking about, XML and very like enterprisey kind of, patterns. And it really took me to shift into the big data world to discover reactive. And what it was I jumped into big data, and people started, the set of problems is very, very different. You talk about huge amount of data, you talk about huge volume, you talk about real-time analytics, this sort of thing. And at that point, a colleague of mine discovered Scala. And right after I started Scala, I discovered Akka, and that's when the light started to turn on, and I just really fell in love with that concept, because when you work with a lot of data, then you have to work with, you need concurrency, you need parallelism, you need distribution, and those are all really hard problems, right? And even like a lot of people have just the basics of what they teach. People don't teach things like actors, they teach like threading and things like that. And what I saw in Akka was that it was such an elegant paradigm that you could have a way of encapsulating state, and you could send messages, and you could think of state as an immutable thing, and that this pattern can scale and has been proven to scale with really large systems like Erlang did and what Ericsson did, right? So this was a really neat paradigm, and I took that and I told my company I'm going to do a sprint to prototype an Akka real-time system, and that actually became our real-time analytics product, which was pretty cool, and from that point on, championed the use of Akka in a lot of places, and developed two major open source, well, I wouldn't say major, but I developed two open source projects. One is the Spark Job Server, which is an Akka-based front job HTTP front end for Spark. And another one is PhiloDB, which uses Akka cluster to coordinate a very large scale time series Prometheus database. And through those projects, I've seen how useful the paradigms of things like Akka can be. The fact that you have location transparency, the fact that you can think about your solution space, and not so much on how do you how do you get the nitty-gritty of things to talk to each other. So I see how powerful it is. I think like as the world goes towards a more streaming model and events and streams become more and more important, that like the existing systems, like if you think about existing systems, like you have things like Spark and Storm, they very much rely on the very traditional ways of dealing with concurrency. You deal with threats. And it's actually, I've put Akka in Spark and I put Akka in Storm and other things. And I think the big barrier will be like education, is getting folks to understand how much potential there is in this programming model and to kind of adapt to it. And I think you see more and more approaches, all the stuff that everyone else has raised about coroutines and about async, and even new programming languages that are trying to do distributed programming right. I think you see that the world is moving in this direction, and that there's a lot of interesting bits and pieces that are coming together. So it's just a matter of, hey, let's swim in this interesting ocean and make it happen. Yep. Thanks very much for having me.
All right, thanks everyone for your introductions. I want to start with the first question for the panel. Oh, I should mention, for those of you wondering, Roland couldn't join us today, wasn't feeling well, so hopefully he'll feel better tomorrow. But anyway, first question for the panel is about the meaning of reactive. And I'll preface it this way. Some of you mentioned a few specific things in your introductions. This is obviously a reactive summit, so most of the people here probably have some idea of what it means, at least to them. So I'd like to hear what you think it means to you personally, and in particular, if there's areas that you think surprised you or that really proved to be impactful when you embrace the ideas of reactive, or even things that you find are common misconceptions about reactive that you'd like to correct. But whatever you want to say about the meaning of reactive is fine.
I can say something about something that I think is a misconception about reactive programming. Like plenty of people say that they use reactive programming when what they actually want to say is they use asynchronous programming, which is a little bit different. Asynchronous programming just means that, like, instead of passing a callback, so having callback may be a form of asynchronous programming, but the idea is you do something which you may have the result later, and you don't want to wait for that specific result. You want to do something else. Versus reactive programming, I think the basic definition of reactive programming is to react to specific event. So both of them are very, very frequently linked. You may have like a fully imperative way of programming your system using like an event loop, and then you just react to events. Everything is completely synchronous. Like you never have callback or things like that. You just react to, you see that specific type of event, you do this. You see that one, you do something else. And you could also have a non-reactive architecture, but you use futures and observables and things like that under those. So just, I think those two things are orthogonal. They are very frequently used together, but I think just a clarification.
Can I say something maybe controversial? I think one of the source of confusion, maybe like difficulty people have, the conflation of kind of two aspects. They're related, but they're different. So we're talking about distributed versus local, like asynchronous. And I think that's one of the issues I had with actors. That's why I stopped using the word actor when talking about the release like years ago. Because actors in the local single process context, they have one meaning. In a distributed context, they really play by different rules. Like you need to think about the different aspects. And I think that's one of these axes, local versus distributed, that would help to clarify. And that's why I like the reactive principles that are much more about distributed, meaning like high scale system, and less ambiguous about that. I don't know if I'm making sense.
That makes a lot of sense. Could I jump in on this one as well?
Please.
I think it helps to also talk about it in sort of the principles, like Sergey is saying. And I feel like if I look at the principles and we look at sort of the core of what it means to be reactive, we're looking at something and we use this word responsiveness, and to maintain high responsiveness, and what I look at in two different ways. And one is in changing environments where you've got failure that's not just possible, but failures that happen. And you've got changing loads, and you've got distribution or locality as well. But really, you're looking at remaining responsive in these very, very much changing environments. And the interesting thing about reactive, as sort of we've put it in, the reactive manifesto, just to put that out there, is it comes with this bit of intentionality with it. When we say, okay, there's this little bit of a distinction between being event driven and being message driven. And when you're doing it message driven, when you have messages that are a part of this where we're helping to maintain that responsiveness, you're able to do things, a couple of things. You're able to be intentional about how you respond in your environments. You're able to do that with a bit of intelligence. And I think that those two key things, being able to be intentional and being able to have intelligence in the way that you respond or the way that you react to things, is what really helps you to maintain a sort of a higher level of resilience in the face of failure, changes, even when you're looking at things like distribution or locality, and looking at things like being just location transparent. Without having that message driven part of it, without being able to have that piece, I think you would lose a lot of the ability to really maintain what I would look at as reactive. And I'm thinking not just reactive programming, which is a lot different, but certainly when you're building a reactive system.
Anyone else want to chime in on this?
Yeah, just to jump in on what Kiki said, I think the message-driven thing is really important. That if you talk about things like, what was that, like coroutines and other things, it is a fundamental difference, like, because it's not anything to do with asynchrony per se. It's more a way of thinking about how those different parts of your application communicate. Because so many people are used to thinking about, they don't think about communication actually. They think about, what is my state, and how do I and naturally, when you start thinking about state, then you think about, how do I change it? Because people think about changing things, and instead it is a different paradigm to think about, how do I message, which is more like how the real world works, right? Where you have people and you actually have to talk to each other. Because you don't go up to, I'm not going to my kid and like, eat her food, right? And like, kind of like it's different plates, and you kind of, I have, or can I share some food? Like that's how the world works. And I think that's sort of what reactive is kind of bringing. And when you think about the paradigm differently, then you kind of architect applications differently.
All right, Alexy, you want to take the next one?
Yes, so we have actually some interesting questions going on in the Discord, so I read through them, and I think the meaning of reactive is often confused by just kind of the word. So let me pose this question. So there is React.js, which is coming from Facebook, and I asked some folks like Steve Gurry, who is at Facebook, and Maurice Erickson, who used to be at Twitter and created Finagle, and now and Ben Christensen. Apparently, the reactive in the backend sense does not yet reach out to React.js. And also, obviously, we have reactive streams versus reactive systems, which I think is the original tension and also productive tension in our foundation. Because, my question to you is, how do you see different meanings of reactive working with each other? For instance, are reactive streams the best way to compose reactive systems? That's the obvious kind of thing. But if you see any other interactions between different meanings of reactive, like React.js, if folks, I'm not familiar much with, with it being fed by, reactive backends, but obviously the different RX schools, RX versus Akka and things like that. So if you guys can can shed some light on that in any order.
Yeah, I don't know why, but this idea that there's this common base in reactive and it evokes these other technologies out there. For some reason, it reminded me of those ridiculous deep thoughts by Jack Handey, Saturday Night Live sketches from the 90s. And at one point, he pontificates, he says, what is the meaning of mankind? Well, the meaning is in the root, mank and eind. And what does that mean? We'll never know. I think we're kind of in that place now as well with reactive. This idea that it reacts to other things is cool. I like that. That's a good definition. But I think a lot of us I think that idea that we're using it to communicate with other things and the other systems to establish a protocol, that's super important, right? To me, that's the big part of it as well, is that protocol between one either intra-VM conversation or across the wire, right? With something like RSocket or Akka.
It's possible that the word reactive has become as diluted as SOA was back in the day.
Oh,
just lost all value.
I like Kiki's point that it's about building responsive systems at the end of the day that are able to respond to traffic.
Yeah, about React. So I'm not an expert in React. That's like front-end side of Facebook. As far as I understand, React is kind of a system when you have components and then you only update the state of those components and you don't re-render the page, but the system by itself finds which component needs to be re-rendered again. So in that sense, it's reactive because it reacts to a state change. When you change something, like you build a website and then you just change like one tiny component, and the system will only redraw the right sets of subcomponents. So that's reactive in that sense. To answer the other question that you asked, Alexy, which is what is the best protocol to link reactive system together? That's exactly the question that I was working on when I was at Netflix with Ben Christensen. So Ben and I were working on RX Java, and which is great because you could build tons of reactivity inside a single JVM, a single machine. But what we wanted to have is the reactivity across the entire distributed system. We wanted, for instance, to be able to connect through a series of servers to last backend, like a database, and be able to do something and consume the data by chunk, and having the system automatically having the client ask the next server, like, give me like 5 items, and that server asking the next one, like, give me 10 items, and up to the point when you reach the database. And then you will only pull the stream at your own speed, and you will have the system that basically react to your ability to pull. So if you have a very slow server, a very slow client, just pull very slowly, and you don't compute tons of data, like you don't pull the entire database and then buffer that to the previous server, that buffer to the previous server, that send that very slowly to the client. The client is dictating the speed at which the database is pulling data from the events. So our socket was designed to be able to do that and link reactivity across the distributed system.
I think ultimately that's about resource efficiency, like it is in the local sense too, where callback-based reactive I/O, or whatever you want to do, but reactive I/O is resource efficiency too. And so I think that's part of the common thread with reactive, is that ultimately we're just trying to be more efficiently use the resources that we have.
Thank you, James. It's over to you, Dylan.
Okay, so this is about the future of reactive. So let's talk about that for a second. What is blocking more people from adopting it? Is it the confusion over what it means? Is it lack of tooling or bad languages? Or what is it? And what do we do about it? Go ahead, Josh.
Oh, me. Okay, so I have been told by every other person for the last 4 years that the thing that makes it hard for them when they start with reactive programming is debugging. And hard to argue, right? There's that upfront learning curve associated with changing your brain to work in the sort of publisher style workflow where you're doing callbacks and whatever. It's like using Java 8 Streams API, but you got back pressure, right? So for some people who've gotten the more Scala functional experience, it's pretty natural. For somebody who's already used the Java 8 Streams API, it's pretty natural. But if you haven't started to think like that, and if you're not willing to like write every single interaction in terms of an API like that, it's going to be hard. And then there's also debugging, which is where on what thread did something vomit? What does this state at this point mean? And so on the reactor team, we've got all these operators that you can call at certain points. I know Akka Streams has similar things, ArcStava ditto. So I know there's all these different things that you can do to sort of do print lines, basically, to see what's happening at a certain point in the pipeline. There's things like getting an assembly trace, that is to say, across what thread boundaries did this Ralph all over the carpet? Where did it blow up? As opposed to just what is this the stack trace from that. And that's the other thing, is changing your mind to do control flow in terms of these pipelines, as opposed to try catch and throwing exceptions and all that error handling control flow. That's difficult for people. For me, as a simpleton, the thing I found the most interesting was learning the vocabulary of the operators of something like Reactor, right? Or ditto for our Akka Streams or ArcStava. I'm not saying only Reactor. I'm just saying there's a vocabulary there you have to learn to understand how to say, I want, to describe the things you would do in regular imperative code suddenly translate into method calls. See what I'm saying? Control flow becomes method calls. Ditto for if you want to compose certain things, there's methods you got to call. So it's just about learning that API. But what I found is, much like people rave about Lisp, I found that once I finally got it, I got it. You know what I'm saying? Like that you have that moment. It's like, oh, okay, this isn't, not only is this not scary anymore, but quite the contrary. I wouldn't want to go back and do it the other way now. And I feel like I would be giving up some of the three characteristics I want in my systems, right? Reliability, ease of maintenance, and composability, right? So not to mention resource efficiency. That's 4. Darn it, off by 1. So yeah, I don't know. That's what I've seen people complain about, is debugging, just understanding what that is. And I don't know, I'd be keen on your thoughts. How do you all address that?
Quick plug on Scala Zio. Scala Zio has really great debugging support for reactive stuff. They've done a really good job of producing a stack trace that actually resembles what you imagine happened versus what actually happened across threads.
There's a comment in Discord that I think kind of encapsulates a lot of the issue. Most people tend to think sequentially. I mean, it's just much easier to think about A calls B calls C and so forth. And do you think we need to be more honest about when you should use reactive, for example?
I guess that's, oh, go ahead. I mean, I would say about when we shouldn't use reactive, maybe if you're saying reactive programming, for example, or if you think a system doesn't need to be resilient or doesn't need to stay up, maybe it's okay. Maybe they don't have customers who will feel bad if they run into glitches. I think that's fine to be honest about it. But I think the thing that would help this, especially if you're looking at debugging and looking at things that go wrong and thinking sequentially, I feel like we have to bring the experience that developers have with building and monitoring and debugging these systems. We have to really bring it away from the stack trace. And we're so used to thinking of the stack trace and thinking sequentially and thinking, oh, it went here and then it went there and then it went there, there and there. And just to be able to really help people to surface what really went wrong, and until we can very, just elegantly and plainly surface what really went wrong, rather than giving people, here, go search through this. Or even with a log aggregator, you're still searching through this in order to determine what really went wrong. And I feel like that's one of those hurdles that we have to get over in the industry in general, especially when it comes to reactive, especially when asynchronous, and especially distributed. Until we can get over that hurdle, then I think that we're going to always struggle with monitoring and debugging. And even though companies have got great tools for it, I mean, even Lightbend can help you. You can monitor and get metrics and debugging information from streams, asynchronous things, I mean, across asynchronous boundaries and everything. But I feel like we have to level up. And until we can level up on this as a whole, then we are going to struggle, and we're going to fall behind as an industry when it comes to adoption and helping people to write good software in this manner.
So as an example of that, I think CQRS is a great way to do like reactive systems, but it's been pretty hard to like actually build CQRS systems. And so I think CloudState is actually doing a great job at making the programming model for that more approachable. So I think there's this evolution where like doing things right and doing things the easy way is hopefully convergent. And I believe that doing things reactively is the right way in most cases, but it's not always the easy way. And there's a lot of times where you have to really struggle with debugging, or with how do I write a system that is, you know, like this woven mess versus this, you know, imperative style. And so hopefully we can continue to converge easy and right, with reactive, of course, being right most of the time.
I'd like to agree with Kikia and James, and disagree at the same time a little bit. I think part of the reason that people struggle with this is when they're given, they say this is the right way, like you have to do like reactive programming. And I think we'll have more successes, we're more inclusive. We say, yeah, imperative is totally fine. Like I would be like one of the advocates saying asynchronous RPC is totally fine and covers more than 50% of the cases. We should not say, yeah, you should do like it in a more complex way. So to me, like the three paradigms, like RPC, which solves a lot of problems. There is a reactive style, but then there is workflow, and that's kind of the reason I changed jobs recently, that those are complementary tools. So if we kind of expand the notion of and focus more on principles, say how to build the reactive systems, as opposed to being like narrow about the specific programming models, then I think it'll be better, see better success in adoption. I don't know if I said something controversial again.
I don't think it's controversial, actually. I'm quite agree with you. I think there are large classes of systems that could be imperative, like, you know, batch processing, where you don't really care about the reactivity or it's not time sensitive. You just need to run something, and it will take the time it needs. When you have a bug, you will see exactly where the bug happened in the program. It will break at that specific point. Compare where one of the problems with debugging reactive systems is that you may be in a situation where you have a bug, and that bug leads to a message being swallowed or not generated. And to be able to debug that, it's more complicated. There is no, like, we can improve the tooling, but it will always be more complicated. Imperative programming, when something bad is happening, you see the error right away. Reactive programming, sometimes you see nothing. Like some thread is blocked somewhere waiting for an event, or like you should have received an event that you did not, or a message that you did not. And debugging that is more complicated. Obviously, you may have like an exception in one of your execution, and then you have like a fake call stack that can give you some information. But when an event or a message is actually swallowed, it's very difficult to debug. And like the most complicated bug that I've worked on were related to events that have been hidden, swallowed, and or hidden in some ways. The other question that Alexy asked at the beginning was why it's not more popular. And I think another reason, like debugging is definitely one of them. The other reason is I see people that want to migrate a fully imperative architecture into a reactive one by a small chunk, and they don't see the benefit. It's very difficult to refactor imperative architecture into reactive architecture. And you have to expect that if you just change one component, you won't see any benefit. You have to change the architecture of the whole system to be able to see really like scalability benefit. And that, I think that's one of the main reasons why people are not migrating towards reactive, that they try, they just change one component and they just see the problems. They just see, oh, it's more difficult to debug. And then they just go back to the imperative systems.
Okay, that one really fired up the RS panel Discord channel, so you might want to check that afterwards. But let's go to Alexy for, I guess, the last question. Or
well, can I just say on that last point? Oh, what was I going to say? We were talking about what's stopping people from learning it. Yeah, darn it. Oh, I had something and I got distracted. It'll come back to me. I'm sorry. Somebody said something great and I wanted to say it, a response. Never mind. It'll come back, I'm sure, one day.
No worries. So we actually have a Q&A following right after our, nominal end time in 3 minutes. So just a heads up, we have a live Zoom room for Q&A. So this will be our first panel Q&A. So after this question, let's all go there. But let me ask something which I learned. Again, all of this is very interesting because you really interact with different industries. So for me, coming from meetup and startup world to kind of corporate setups was very interesting. First of all, by the way, I want to say, Evan mentioned XML and enterprise patterns, and we're now, many years later, YAML and enterprise patterns. Right? So some things don't change. But so Steve in the Reactive Foundation, he's a board member, and we had conversations throughout the summer. And so I heard this from Steve, and I heard it from Stefan Maldini over at Netflix. I think the biggest hurdle in the big legacy code bases for reactive is that essentially you cannot be a reactive island, because in order to leverage end-to-end benefit, you need to basically disrupt everything, and it's very hard. And I think Ben Christensen did a lot of work at Facebook and some Herculean work, and I think he hit some obstacles as well. So I wonder, how do you guys bring reactive not too easy, smart greenfield startups of San Francisco, but to Midlands of America and to corporate kind of big corporate setups?
I remember what I wanted to say. Somebody suggested that what was they were saying that should we be more honest with some of the limitations of reactive programming? To which I wanted to say that first of all, I have done my part in almost all of my presentations to speak to the adverse less than ideal situations in which you can use reactive programming, if only because, first of all, security is something that's top of mind for a lot of people. When you talk about cryptography, that's naturally not going to be reactive. You're going to need to run that on a CPU somewhere. And then second of all, it gives me a chance to make fun of Slack, which takes all my CPU power. So at every single presentation I've done for the last 4 years, I've made fun of Slack. And I think I deserve credit for that. Them for being terrible and me for reminding people of that for 4 years. So I think, yes, we could be more honest. Slack could use less memory and we'd be okay, right? I think that's true though. I think you're right in general that we do need to be more clear about the limitations. Security is really big. It's not like that went away, right? We can't rub reactive on that and make that better. So like cryptography, any algorithmic thing is going to be less than ideal when it comes to reactive programming. So you have to be smart about isolating that, right? And it's always been true that you need to be smart about isolating that and putting it on its own thread pool and making sure that it doesn't monopolize the threads being used for the front-end web pool, for example. But now it's just at least we have the tools and the understanding to be explicit about it, which I like. Sorry for the late rejoinder.
So do we still have time to answer your question about enterprise and messy environments?
Yes, please.
I would just quickly answer into that one because that's where I learned reactive. So I did not get the benefit of learning Akka in a beautiful greenfield environment where I could build something that lived off on its own reactive island. When we say stuff like I learned it in anger, I really did learn this stuff in anger in environments where it was an enterprise environment. That was my background. I was I worked at a large consulting firm for enterprises doing system integration, and trying to use reactive in that environment was very, very difficult. And I think that I was I was very myself resilient and really wanted to do it and really believed in it. So I pushed it forward super strong and kind of sometimes drug it in there. But I don't think people will do that today. I don't think a lot of companies are going to do that. And I think that we do have to change the way that we present reactive or present building these architectures in order to get companies to build into this so that they do see the benefit of it without one small component at a time and are able to integrate with other things that exist in the world, other applications, legacy applications or heritage applications, whatever you want to call them. They exist. They're not going away a lot of times. And one of the things that we have to do to make it more attainable and make it more usable is to really, in my mind, I think, is to level up away from getting people to learn actors and learn Akka itself. I think that's an admirable goal. I think it's something that people can do. I don't think that is a question of competence at all. I think it's a question of how you're efficiently using your human resource, right? I hate to call myself a resource, but we too have limited resources. We are limited beings, and we have to use our skills very wisely. And that reminds me, I think, James, you mentioned cloud state. That reminds me of why I feel like, cloud state is going to really help bridge the gap there. And it's not just cloud state. Other people are coming up with this model where you have stateful serverless. You have this idea of serverless, but you're preserving state, and you're doing it in such a way where you're able to have this reactive architecture underpinning your function as a service, so to speak, without having people to build that entire architecture underneath it. So now you're able to have developers who can do one component at a time, one piece at a time, and still see the benefit of that without having built that entire reactive platform under it, that reactive foundation underneath it. And Cloud State IO is not the first, it may be the first, I don't know if it's the first, but Cloud State IO is certainly not the only platform that's looking to do this or that is working on this right now, but it's certainly one to take a look at if you're thinking about, okay, I want to know about, how can I get the massive benefit of a reactive system, and in this case, an Akka-based architecture, without building it myself, without building Akka myself, and still being able to capitalize on that with whatever I'm building. I think that's where we're going to have to go as an industry to give people the foundation. We used to think like, oh, if we give them the framework, then they're going to be able to build this thing out. If we give them the library first, no, we don't give library, we're going to give them a framework. No, framework didn't work. We're going to give them templates. No, that may not work. We're going to have to actually give people a full foundation to build on top of, where they can, okay, now I can run my function as a service and it's stateful, and I didn't have to build anything underneath it. And that's where I think that we're going to have to go just as an industry in order to get people to, in order to get reactive to live in those sort of messier environments.